let's talk about our heat math formulas. Our first one that we're going to use, and this is used mostly, is the Q equals MC delta T, where Q is your heat energy in joules, M is the mass in grams, delta T is T final minus T initial, and C is one of our constants. So this formula is used only when you have a change in temperature. So you're going to be on a slope, either here, here, or up here. You cannot use this formula on a flat line. So let's talk about this C. So specific heat capacity is a constant, and it's a number. It'll be given to you. But the key thing to remember about specific heat capacity is that it varies with phase. It has a derived unit, so it has the unit of joules for every degree C times grams. So let's look at an example that uses this formula. So our question is, a cup of coffee, which has a mass of 140 grams, cools from 80 degrees Celsius down to room temperature at 20 degrees Celsius. How much energy was released? Now, the first thing you have to do when you read this question is to decide, do I need a heating curve or a cooling curve? If energy is being released, then the coffee is cooling, and we'll need to draw a cooling curve. Now, the cooling curve, since our coffee is mostly water, we'll use waters, boiling and freezing point. So if we look at our temperatures that are given, we're starting at 80 degrees, which would be less than 100, and we're dropping to 20 degrees. So this is my T initial, this is my T final. And they ask us how much energy was released. Well, notice my entire energy change is on one section of the graph. It is on a slope, so I can use my Q equals MC delta T. So the mass is 140, which is given. Now, since we're in the liquid phase, we'll use the liquid specific heat of water, which is given on your worksheet and on your tutor chart. But its value is 4.18 joules for every gram degree C. So there's our C. And our delta T is going to be our T final minus T initial. So our T final was 20 degrees minus 80 degrees. So our total delta T, our change in temperature, is negative 60 degrees C. Now the question asks us for energy, and that is Q. So at this point we just have to multiply. So we'll take out our handy dandy calculators and do just that. So we'll do 140 times 4.18 times negative 60. Now realize that this answer, since our grams divided out, our degrees C divide out, this answer is in joules. Now typically we'll keep 3 sig figs. And we usually don't even give our answers in joules, we give them in kilojoules. So we'll divide by 1,000, and that'll give us 35.1 kilojoules. Negative kilojoules. Now remember, this negative means that the energy was lost from the coffee, and that is true. It's not a negative number as in a negative number on the number line, it means lost. So you could say 35.1 kilojoules of energy was released to the surroundings. And that will fully answer this question. But we have 2 other formulas, and we need to check them out.